Hi folks, some of you last night in seminar indicated you were having difficulty with problem number 8 in the Unit 6 homework, so I thought I would go over a similar problem with you. This is not the exact numbers as in yours, but it's very similar. What it asks is, or what it tells you is that there is a safety light which is designed so that the times between flashes are normally distributed with a mean of 3.5 seconds and a standard deviation of 0.7. And so in the beginning, that's really all we need to know, because what we can do with that, based on that one sentence, is just sketch, a normal curve, looks like that. And what we know is that the mean is, it's mu, 3.5 seconds. And the standard deviation is 0.7 seconds. So this horizontal axis is in terms of x, which is in seconds. And we know the mean is 3.5. And we know the standard deviation is 0.7. So just for reference, one standard deviation above the mean would be 3.5 plus 0.7, or 4.2. And a second standard deviation above the mean would be 3.5 plus 0.7 and another 0.7. Or you could just add 0.7 to this one, which would be 4.9. We do that just to give us a reference, because in part A it asks what's the probability that an individual time, one time, is greater than 4 seconds. And so we know that 4 seconds is, right in here someplace. That's 4 seconds. And they want to know the probability that a single flash is lasts greater than 4 seconds. So there's a couple of ways you can do it. You can convert this 4 to a z using x minus mu over sigma and use the tables. But as you know, I prefer to use stat crunch. Now, but just look at this for a second before we even do anything. Notice that the mean is at 3.5. The mean's at 3.5. And this area that they're interested in, the cross-hatched area, is less than that. Here's the, there should be a straight line. Here's the mean value right there. That whole half of the curve to the right is 50% of the data lies to the right and 50% lies to the left. So the crosshatch area, our answer's got to be less than 0.5. It's got to be less than 0.5. So what I'm going to do is I'm going to go to stat crunch, and if we go down here to stat crunch, I'm going to go to stat and calculators and normal, and it's going to give us this normal curve. It wants to know the mean and the standard deviation, and from our problem, the mean is 3.5, so we're going to put 3.5 in here. The standard deviation is 0.7, so we're going to put 0.7 in there. And it wants to know, our problem wants to know, what's the probability that the individual time is, one individual time is greater than 4. So what we need to do here is we need to change this sign. We want it to be greater than equal to 4 seconds. 4. Plus enter to compute, and there it is. It's 23.75%, 0.2375. And it shows you the area that we had shaded right in here in red. And so for the probability a single flash is greater than 4 seconds is 23.7%. Now, the second part says find the probability that the mean for 60 randomly selected times is greater than 4. That's a big difference, because now we're not looking at a single flash, but we're looking at a sample of 60. In other words, they took a sample of 60 flashes and timed them, and they want to know what's the probability that the average time between flashes for those 60 is greater than 4. So what we have to use here is called the central limit theorem. We use that whenever our sample is greater than 1. Here it's 60. In part A it was 1, see, and individual time, but in part B it's 60. The big difference here, instead of using the standard deviation that they originally gave us, 0.7, since we're using the central limit theorem, our new standard deviation is sigma over the square root of n, which means 0.7 over the square root of 60. That is what we're going to have to use as our new standard deviation, 0.7 over the square root of 60. So the square root of 60, if I can grab a calculator here, let's see, I'm going to put in 60, square root is 7.746. And so what we have is 0.7 over 7.746. This is our new standard deviation. Let me see what this is. 0.7 divided by 7.746 equals 0.0904. 0.0904. That's our new standard deviation. That's the big difference now that we have to remember to do whenever our sample size is greater than 1. So what we're going to do now, they still want the probability that the average is greater than 4 seconds. We're going to go back now to our StatCrunch, and here's StatCrunch right here. Now what we're going to do is say our mean is 3.5, but now our standard deviation is 0.0904. I change the standard deviation. We still want the probability that x is greater than equal to 4. We're going to compute, and look, it barely shows. The probability is so low that it doesn't even show on here. It's essentially 0. And so what that means is that the probability that the average for 60 random selected times, the average time between flashes being greater than 4 seconds, is essentially 0. That may be what's causing part of the problem, because as you see here, it doesn't even register and nothing's in red because this probability is so low. It's way out here someplace. So the final part asks, given that the light is intended to help people see an obstruction, which result is more relevant for assessing the safety of the light? Well, I always like to see more data rather than less data. The first one was just an individual time. Doesn't mean much because it's a single instant, whereas the second one is an average for 60 times. So I always like to select more data, the mean for 60 randomly selected times. Use StatCrunch. It's a lot better than and faster than the tables. Okay, hope this helped. And if you have any questions, make sure you email me, afiducia@kaplan.edu.